Let's get it, Algebra 1 Truman, Mr. Sluto's class. So, what we're doing is we are finding slope-intercept form from a graph, which is awesome and fun because I love when things are easy, but I do have a plan when things get rough. And that's what math is about, having the logic and understanding the patterns to manipulate the unknown with the knowns that you're provided. So, let's get it. So first, I'm looking at this graph, and if we're going to talk about slope-intercept form, that is y equals mx plus b. It's just what it is. Where m is your rate, and your rate always goes with that variable because this number is going to change every time that number changes. And then your b, your back number, is your starting point. That's your initial fee. So when we did our river problem, after it rained, it was 34 feet high. So that's just the starting point, and we're always going to reference that. And then it receded at a rate of half a foot every day. So as these days change, how far down it goes change because you're going to multiply those two. Just reminding you of how awesome you are. So if that's the case, none of these have numbers on them. So we're just going to go by one. That matters, especially with your y-intercept. So for like right here, this is the origin. The point where it crosses is 0, 0. Your y-intercept is when x is 0. So that x is 0, that's your y-intercept. So your b equals 0. Your slope is rise over run. So if you go from these 2 points, see that little rectangle? It's so pretty. Triangle. So you go up 1 and you go over 2. So when you put those together, your y equals your slope, which is 1/2 x, and your back number plus 0. If I wrote this in function notation, so f of x, so whenever I plug in a different number, I'm going to get half of what I have. 0 stands for nothing, so we're cool. On your back sheet, you will find this. You will not find that. So please make sure you find both. So let me find one that's going to be a little trickier. Because if I use my relationships, real talk, I don't have to do all this. Because I can look at this and say this is my y-axis. And it's going to cross at 1, 2, 3. As long as each of these lines are worth 1. So my back number equals a -3. And then my slope equals, so I'm going to use their points. And this is going to be up 2, back 2. So my rise is up 2, my run is back 2. That's going to be -1. So this is y equals -1x minus 3. Or it could be y equals -x minus 3. But in function notation, let's just say these functions are different. So I'm just going to give it a different name. Equals negative minus. Let's go. This is an equation. This is function notation. Equation, function, notation. Let's get it. So I'm going to do one that's a little trickier. For example, on number 3, I can't do what I just did. It looks like half, but I'm not sure. So I'm going to have to use those points. Okay. So my slope equals 1 over 2. So 1/2. That's going uphill, so I know it is positive. So I'm going to have to find a point. Please make sure you always check a graph scale before you start doing this, because it's going to throw off your y-intercept. It won't affect the slope because your rate of change is your rate of change, but it will affect your y-intercept. So let's do this. So I have a point at 1, 1, 2, 3. So I have a point at 1, -3. I could have chosen my point at 1, -4. Didn't matter. So I can use point slope form. I can use slope-intercept. On a test, I don't care what you use. I care that it makes sense to you. So me personally, this is my jam. So my y is -3. My slope is 1/2. My x is 1, and I'm trying to find what that is. So -3 equals 1 times anything is what it was. So, oh, I need to subtract 1/2. When the signs are the same, you find the sum. So basically, I'm adding these together. So this is now going to be -3 and 1/2, which is the same as 2 times 3 is 6, plus 1 is -7 over 2. Equals my B. That's, right? Just being clear with my notation. I don't want you to be thrown off because these canceled out. So this is y equals, my slope was 1/2 x. My y-intercept is -7/2. I prefer mixed numbers in that situation, because you're less likely to miswrite that as -31 over 2. And it just makes it easier. All right, so I am looking for equations and function notation. So this function is different than those. So this function notation, so what are f, g, let's go h. So h of x equals 1/2 x minus 7 over 2. Ooh, I love this. H of x could also equal x minus 7 over 2. All those are the same. Equivalent forms goes back to Unit A. All right, get at it, Truman.